This is the drill press. It's used for drilling and boring and offers a lot of advantages that a hand drill doesn't. As far as safety goes, we want to make sure that we don't have anything caught in the spindle as it's spinning. So please make sure to tie back loose hair, loose clothes, or loose jewelry. You also want to maintain your margin of safety, so keep your hands and fingers 2 to 4 inches away from the drill bit at all times. Let me point out some features on this drill press. We've got our on-off right here. This machine won't stay on unless we have our guard clicked into place. Our wheel up here can increase or decrease our RPMs. Our display up here shows us what the RPMs are as well. We have our tabletop that we're working on. This can be raised, lowered, and rotated. On the right side here, we have a threaded gauge that allows us to set our depth of cut. And we have our handles over here for actually using the drill press. So let's talk through an example of how you would actually use it. There's a few setups that you need to do before using the drill press. The first is your drill bit. You might be using a multi-spur bit or a general twist bit. Either way, we need to load it into the chuck. So any drill bit is going to have a shank on the end, and you only want to insert about 1 inch of the shank into the chuck. Oftentimes, people want to push it all the way up until they feel it stop, but sometimes that grips on the bladed auger, which you don't want. So about 1 inch into the chuck is sufficient. This chuck can be adjusted by hand. So if I'm using this Forstner bit, I can get it as tight as I can by hand, but then I want to snug it into place with a chuck key. The chuck key is inserted to the chuck. Those teeth match up, and then I can give some additional tightening to that bit. You don't have to use all of your strength. You don't want to make it too hard for the next person to get it out, but you do want it to be nice and snug. Now, it's really important to remember to take the chuck key out of the chuck. If you were to leave the chuck key in the chuck and turn it on, then obviously that could be really dangerous. That would get thrown. So we remember to remove the chuck key from the chuck. Now I've got my drill bit in place. The next thing that I want to set up is my table height. So I want to bring my table as high as I can, but still being under the drill bit. On the side over here, on the left side, there's a clamp. You loosen that clamp, and then on the right side, okay, there's a wheel, and you can either lower or raise the height of the table. But then we don't want that table to move, so we'll clamp it down again on the left side. So now our table is set and it doesn't move. The next step is to check your depth of cut. We don't want to drill into our nice metal tabletop, so we want to advance the drill bit and see if it's going to touch. And in this case, it would. So over here on the right side on this threaded gauge, I'm going to spin these hex nuts down and get those set into place so that now it stops before I hit the tabletop. I do recommend using a scrap board underneath whatever material you are drilling. And so I often keep small plywood offcuts just for that reason, so that I can have that underneath. It doesn't matter to me to have this drilled into, because that can just be thrown away. And then it supports the material that you're actually drilling through. The next thing that you want to check is your RPMs. I'm going to bring my guard into place. You want to hear it click. That tells you that the drill will stay on once you start it. So I can see right now that I'm at nearly 1,200 RPMs. This is a relatively large bit. If you're using a drill bit that's about 1/2 inch or larger in diameter, That is considered to be a large diameter bit. And so I'm going to set my RPMs down about 800 or so, less than 1,000. So you turn it on and then you can adjust it with the wheel here. So now I'm just about at 800, which is right where I'd want to be. The next thing to double check is just to remind yourself that you want to keep your hands and fingers away from that bit. If your material is large enough, then you can carefully hold it by hand. But it's always a good idea if you'd like to clamp that in place. That's always a nice, safe option as well. Generally, if it's smaller than your hand, it's going to cause you to be too close to that drill bit when you hold it in place. In that instance, you really would need to use a clamp. I also have these vices near the drill presses as well to use for small material. You'll notice that I have some notches cut into the centers, and that's specifically for cylindrical material like pens and things like that. So I've checked each of the things that I needed to. I safely put my bit into place. I checked the table height. I checked my depth of cut. I checked my RPMs. I've got a scrap board underneath, and I'll be able to safely make this cut. I can cut all the way through, or sometimes you'll have a specific depth that you're cutting to, but not all the way through your material. You want to make sure to take small bites into the material and allow it to clean out those chips for a cleaner cut. If you cut too aggressively, then you'll get torn grain. You won't get a very clean cut. So we're ready to go. Typically, you'll hear, see, and feel when you get through the bottom of that material. If you've done a good job, it should be pretty clean on the bottom. That's where tear out would happen. And I want to make sure to clean off my drill bit of any chips before I would make an additional cut. For this example, I just drilled into a random place on my material. But obviously, if this was for a project, I would want to have a mark of where I want that center point to be. So that was an example of using the drill press safely. I'm going to remember to remove the drill bit, okay, using the chuck key. And I'm going to make sure to return this to the tool cabinet where it goes so that I can find it or another person can find it the next time that they need to use it. So that's the drill press. Please make sure to follow all the safety guidelines as you're using this machine. I also want to point out a few things on hand drills as well. Here's an example of a typical drill and driver that you might see in a shop or at home. And these are the type that I have in my shop as well. So this is my driver. Drivers are used for driving with different driver bits. The most common of those is the Phillips bit. And you'll notice that this doesn't have the normal chuck. So this just inserts into place. And then to get it out, then you just pull on this collar and it slides out of place. Okay, a driver sounds like a drill. And you'll notice as you're driving screws or different material that you'll hear it starts to click as it's getting close to the end. This does have a forward and reverse button on it, on either side. And if you need to remember which one is which, it has a little arrow printed on it. So if I want to drive forward, then I would push that into place, and reverse would be on the back side. So that's a driver that you would mostly use if you're driving screws, bolts, things like that. This would be a drill that could be used similar to the drill chuck. So you'll see this has a keyless chuck that can just be twisted. So if I were loading a drill bit into this chuck, then I would just put that into place and then tighten it up, righty-tighty, and that would be good to go. Now, you'll notice a couple of things on this drill. Okay, on the top, you've got your 1 and your 2, and that's your speed. I typically always just leave it on 1. I feel like I have a little bit more control doing that. So this collar is called the clutch. This symbol means that it's using 100% of its torque and 100% of its power, and it will do that until the drill motor burns up, basically. But oftentimes, you don't want to apply quite as much torque. You don't want to strip a screw head. You don't want to break a screw head off, things like that. So you can control the torque with the clutch setting. So if I spin this down to 1, now as I drill, if I apply very little pressure, you'll see that it stops spinning. As you increase that number, then it increases the torque and the pressure. So I have to squeeze a little harder to get it to stop. Now, obviously, I wouldn't be squeezing it like that when I'm actually using it, but as the drill bit experiences resistance when you're drilling, then at a certain point it would stop. This is a really great option, especially when you're driving screws and things like that using a normal drill. If I'm actually drilling holes, then I just have it set on the drill setting. But if I'm driving screws, I'll decrease the clutch to maybe 8 or 9, somewhere in that range. Either way, just remember in my shop that when you're done using one, you should remove the drill bit or the driver bit and make sure that those get put back in the correct spot. So we've discussed and shown an example of the drill press and given a few tips on hand drills as well. Please make sure to follow all the safety guidelines for these tools as you use them in my shop.